You have been alive for roughly 700,000 hours, and the universe has been running for 120 trillion of them. And in that entire span, every star ignited, every ocean formed, every species that arose and vanished without a trace, all of recorded human civilization fits inside the last 10 seconds. Not 10 years or 10 centuries, but 10 seconds of a 14 billion year calendar. And that number should not simply make you feel small. It should stop you completely and then fill you with something equal parts terror and wonder. Most people hear that the universe is 14 billion years old and nod politely, filing it away as a long time before moving on without really absorbing what that means. Human intuition was built for seasons and harvests and generations, not for billions of years. And the gap between the number and any felt sense of it is exactly the problem. Our brains are, almost comically, the wrong instrument for measuring this kind of time. You probably think you understand how old humanity is. Egypt, Mesopotamia, thousands of years of kings and wars and philosophy and art. That feels like a deep reservoir of human experience. And in one sense, it is. But as a measure of time, it is so incomplete that it might as well be nothing at all. What follows is a tool, not just a number, but a way of actually feeling the shape of time itself. Compress every event from the Big Bang to this moment into a single calendar year so that January 1st at midnight is the universe erupting into existence, and December 31st at 11:59 p.m. and 50 seconds is right now, this moment, you reading these words. Every star that has ever burned, every world that has ever formed, every living thing that has ever drawn breath on any planet anywhere in the observable universe fits inside 1 year. This is the cosmic calendar. And once you walk through it, you cannot unsee what it shows you. January 1st at midnight, the Big Bang arrives. From a state of density and temperature so extreme that current physics breaks down entirely, all of space and time and matter and energy erupts outward into a darkness without stars, without warmth, without any structure at all. For a long while, there is only hydrogen and helium spreading through a void that contains nothing else. By May of that cosmic year, the Milky Way starts pulling itself together from the slow gravitational gathering of ancient gas and the first generation of stars, and it is not until September 9th that our sun ignites in the outer regions of the galaxy, with a disk of material swirling around it, beginning slowly to clump into worlds. 4 rocky inner planets take shape, and the third one, positioned at just the right distance from the heat, begins to cool. What happened about 100 million years after that still carries a kind of quiet astonishment. In late September of the cosmic calendar, a planet-sized object called Theia struck our young world in a catastrophic collision, and the debris from that impact coalesced into the moon, that familiar presence in our night sky that turns out to be the scar of an ancient catastrophe. By late September, in the warm chemistry of shallow oceans on the newly stabilized Earth, something stirs. Life begins, not complex life and not life you could see, but single cells called prokaryotes, the most ancient and durable life form this planet has ever produced. They arose with what, in geological terms, amounts to unseemly speed. And then they persisted for 2 billion years, from late September until well into November of the cosmic calendar. Prokaryotes ruled the Earth without serious competition. 2 billion years of chemistry, so subtle you could hold the entire living world in your hands and not know it was alive. For more than half the history of life on this planet, a single cell was the summit of complexity. No eyes, no nervous system, No movement by choice, just molecules replicating themselves, metabolizing, persisting. And that is what alive looked like for most of Earth's biological history. November is when eukaryotes appear, cells with internal structures and a nucleus, and the first hints of cooperation between parts. And from mid November onward, organisms built from multiple cells begin assembling themselves from components that had previously only existed alone. Evolution, working with the patience that only deep time allows, starts building bodies. And then comes December. The first days of December bring what Charles Darwin himself called the mystery of mysteries, the Cambrian explosion, when 500 million years ago, complex animal body plans appeared in the fossil record with a suddenness that astonished every paleontologist who encountered it. Eyes and legs and mouths and predation, the entire ecological theater of animal life, hunter and hunted, camouflage and armor, all of it switched on within a few million years and on the cosmic calendar that occupies perhaps December 1st and 2nd. The diversity of life we recognize today traces its origin to those two cosmic calendar days. The Phanerozoic eon, the entire age of complex, visible animal life on this planet, fills the last 31 days of the year. The first fish, the first forests, the first amphibians dragging themselves onto land, the first reptiles, all of it in December, and arriving around December 15th. The great ruling dynasties of the Mesozoic, the age of dinosaurs. Here is where it gets genuinely strange and worth stopping on for a moment. The non-avian dinosaurs did not appear for a moment and vanish. Ruling this planet completely, in extraordinary diversity across every ecological niche, from roughly December 15th to December 29th of the cosmic calendar, they held their dominion for 160 million years of actual time, 6 times longer than the entire span between their extinction and today. Call the post-dinosaur age of mammals one era, and the dinosaurs had 6 of those eras before we arrived. Our species is not the author of this planet's story. We arrived in the final sentence of the final paragraph of the final chapter, and we have been here for almost nothing. And here is the thought that carries the most weight. Consider what it would mean if, somewhere in the final million years of their reign, some lineage of dinosaur had developed social complexity, tools, language. By geological reckoning, it would have lasted an eye blink, and the entire record of their civilization would have dissolved into the fossil record without a trace. We would never know, and we cannot know. That possibility connects directly to a question the physicist Enrico Fermi raised at a lunch table in 1950, asking why, in a galaxy 400 billion stars wide with billions of potentially habitable worlds, we see no evidence of intelligence elsewhere. The cosmic calendar may carry part of the answer. Intelligence, by this measure, appears to be new and fragile, with a window that may be narrower than we would like to believe. December 29th, a rock approximately 10 kilometers wide called the Chicxulub impactor struck what is now the Yucatan Peninsula with a force equivalent to billions of nuclear weapons, triggering a global winter that ended 66 million years of dinosaur dominance within thousands of years. The crater it left, buried beneath the Gulf of Mexico, is still there today. One rock, one collision, a complete planetary reset. December 26th brings the first primitive primates, small, sharp-eyed creatures moving through ancient forests. The 28th is when the great apes diverge from the old world monkey lineage. On the final day of the entire cosmic year, December 31st, the hominid line begins its long branching walk toward something we would recognize as human, but the early hours of that last day are still far removed from us. Around 10:30 p.m. on December 31st, Homo sapiens, our species, with brains and bodies identical to yours, emerge onto the African savanna. 200,000 years of actual time translates to the last 90 minutes before midnight on the last day of the year, and every human being who has ever lived, every language ever spoken, every love ever declared, every god ever worshipped, all of it happened in those 90 minutes. Now stop, because this is the part that most treatments of the cosmic calendar move past too quickly. All of recorded human civilization, every empire, every discovery, every catastrophe we study as history fits inside the last 10 seconds before midnight on December 31st. The agricultural revolution, when humans first planted crops and domesticated animals and stopped following the herds, happened 10 seconds ago. The first cities of Sumer in Mesopotamia, Uruk, and Eridu, the earliest urban experiments in human memory, arose 7 or 8 seconds ago. Ancient Egypt at the height of its power, the Great Pyramid standing new and white-cased in the desert sun, was 5 or 6 seconds ago. Classical Greece, where democracy and philosophy and geometry were being invented simultaneously, was 3 seconds ago, and Rome came 2 seconds after that. Consider what that compression actually means. The entire span from the first Sumerian writing system, marks pressed into clay tablets to record grain inventories, to the detonation of the first nuclear weapon above the New Mexico desert amounts to approximately 3 cosmic calendar seconds. From clay tablet to atomic fire, from the first scratched symbol to a device capable of ending civilization, 3 seconds of a 14 billion year. The whole distance covered in 3 seconds. A Scottish geologist named James Hutton stood at Sicker Point in the 1780s and looked at the rock strata there, and what he wrote was that he saw no vestige of a beginning, no prospect of an end. Hutton was the first modern mind to genuinely feel deep time, to grasp that the earth was not thousands of years old, but incomprehensibly ancient, and his insight was both revolutionary and barely noticed at the time. In the cosmic calendar, that happened less than a second ago, and everything built upon it, the entire science of geology, the discovery of evolution by natural selection by Charles Darwin, the decoding of the genome, the detection of gravitational waves from colliding black holes, all of it fits inside less than 1 cosmic calendar second. We are so new, not as a metaphor or a figure of speech, but as a plain statement of where we actually sit in time. Consider what this newness means for the state of human knowledge. James Clerk Maxwell worked out the laws of electromagnetism, the physics behind every light bulb and radio wave and electric motor on Earth in the 1860s. Less than half a cosmic calendar second ago, Isaac Newton published the Principia Mathematica, the foundation of classical mechanics, in 1687, which amounts to 0.001 cosmic calendar seconds ago. Francis Crick and James Watson decoded the structure of DNA, the molecule carrying the operating instructions for every living thing on Earth, in 1953, less than a tenth of a cosmic calendar second ago. And plate tectonics, the science explaining how continents drift and mountains rise and oceans open, was not accepted by the scientific community until the late 1960s. We did not understand how our own planet works until the last hundredth of a cosmic calendar second. Science, in its modern, rigorous form, has been running for roughly 400 years, and what we have learned in that time is staggering. But what we have not yet learned is almost certainly far, far larger. Right now, orbiting 1,000,000 miles from Earth, the James Webb Space Telescope is collecting light that left its source over 13 billion years ago. Light from the first galaxies to form after the Big Bang, which means we are literally looking back to January of the cosmic year from our vantage point in the last second of December. We are an infant species that has just learned to read, attempting to decode letters written before the Earth existed. And the fact that we can do it at all is among the most astonishing things I know. There's a library that carries a particular weight in this story. The ancient library of Alexandria gathered the accumulated work of Greek mathematics, Egyptian astronomy, Persian philosophy, centuries of careful observation about nature, including the astronomical records of Hipparchus, the geographic calculations of Eratosthenes, and the heliocentric hypothesis of Aristarchus, who understood 2,000 years before Copernicus that the Earth circles the sun. All of it gathered in one place and all of it lost, not in a single fire, as legend has it, but gradually, over centuries of neglect and conflict and political indifference until it was simply gone. The knowledge of Aristarchus was buried, and the Greek understanding that the earth moves went forgotten for nearly 2,000 years. In the cosmic calendar, the Library of Alexandria burned less than a second ago. The centuries of intellectual darkness that followed filled less than half a second, and the recovery from that loss, the painstaking reconstruction of human knowledge that began with Copernicus and Galileo and accelerated through Newton, started only in the last fragments of the final second of the year. The beginning is where we actually are, and not metaphorically. The universe is not old by any measure of what still lies ahead. Stars will continue forming for another 100 trillion years, which is 10,000 times the current age of the universe. And the era of stellar life we inhabit is early, proportionally similar in its development to a 30-year-old human who has barely reached adulthood. If intelligent life continues to arise on planets circling stars that have not yet formed, the 10 seconds of our civilization will seem primordially ancient by comparison. This is not a late chapter. This is the first sentence of the first paragraph. All of this, the prokaryotes and the Cambrian and the dinosaurs and the 3 seconds from clay to nuclear fire, happened on one world, orbiting one ordinary star, in the outer spiral arm of one unremarkable galaxy. And yet, here we are, using atoms forged in stellar cores and scattered by stellar explosions, using brains assembled by 4 billion years of evolution to understand how all of it happened. The calcium in your bones was forged in a star that died before our sun existed, and the iron in your blood was scattered across interstellar space by a supernova approximately 4.6 billion years ago, perhaps 50 light years from the nebula that would become our solar system. That explosion, which had no witness and left no monument, seeded the solar system with the heavy elements that make complex chemistry and complex life possible. You are, in the most literal sense available to science, the rearranged debris of dead stars, and through you, the universe began to understand itself. We have been doing that understanding with real rigor, with instruments and mathematics and disciplined skepticism for one cosmic calendar second. In that second, human activity triggered measurable global climate change, making us the first species in 4 billion years of biological history to deliberately alter the chemistry of an entire planet. In that same second, we built weapons capable of ending civilization entirely. And in that second, we also sent Voyager 1, now more than 23 billion kilometers from the sun, and still transmitting beyond the boundaries of the solar system, carrying a golden record encoded with the sounds and images of a world that wanted, even briefly, to be remembered. In 10 seconds of a 14 billion year, matter arranged itself into something capable of being afraid and hopeful and curious and reckless and capable of tremendous beauty. And that combination, all of those things living inside the same creature at the same time, may be the most extraordinary thing in the known cosmos. The universe runs no rescue operations. There is no law of nature guaranteeing that intelligence, once it arises, survives. The dinosaurs held this planet for 160 million years before a rock ended their reign in a matter of seasons, and we have built tools that could end ours in an afternoon. But we have also built something the dinosaurs never had, which is science. The accumulated and self-correcting body of knowledge about how the universe works, including the cosmic calendar itself, the ability to step back far enough to see our own newness, our own improbability, our own extraordinary fragility. We have been asking careful questions about the universe for one cosmic calendar's second out of a full year, and what we do not yet know is almost certainly magnificent. The universe has 100 trillion years of star formation ahead of it, and we are here in the very first chapter, barely past the opening line, still learning the alphabet of things. That is what human history really is. Not the chronicle of empires and catastrophes we were taught in school, but the first trembling moment of the universe becoming aware of itself, brief and fragile and unprecedented and almost impossibly precious, 10 seconds in which the cosmos opened its eyes. And what it sees next depends entirely on what we choose to do with the seconds we have remaining.